Determining the period of an object in uniform circular motion due to the gravitational force from another object. How long will it take a planet 150 million kilometers from a star of mass 1.99 times 10 to the 30th kilograms to complete one full orbit? Well, if you listen to the previous skill, we derived an equation for velocity from both the centripetal force equation and the gravitational force equation. And we got velocity to be equal to g m1 over r, the radius. And m1 being the object in question, and this would be the planet. So, listing out some information first. Before we dive too deep, I wanna get all our key information in. We have our constant 6.71 times 10 to the negative 11. We have m1 equaling 1.99 times 10 to the 30th. This is just a great habit to always write down all the key information. And then we have 150 million kilometers. And that's actually going to be equal to approximately 1.5, not approximately, exactly 1.5 times 10 to the 11th meters, and you can figure out that conversion on your own. Now, we know that v is g m1 over r. We also know that from the velocity equation, we know that for uniform circular motion, velocity is equal to 2 pi r divided by the period t. So what we can do is we can set these two equations equal to each other. We can set this equal to g m1 over r. And we can basically isolate and solve for t. Once we go ahead and manipulate this formula, we get t equals 2 pi r to the 1.5 divided by the square root of g times m1. When we go ahead and plug in our information, we get an answer of 3.17 times 10 to the 10th seconds, which is equal to, once you go ahead and convert this to days, you get a total of 366 days. Now, that sounds very similar. So one full orbit is also considered the year. So how long is the year for this planet? The year is 366 days. This is not a coincidence. The planet we're talking about is Earth. And the star is the sun. So a little clever problem. You didn't really know what Earth and what planets and star we were referring to, but the planets, this is how you actually get the calculation for the length of a year for Earth.